Okay viewers, we're running our 24,000 BTU 2-ton Samsung window air conditioner. I'm actually doing a temperature test. This thing is cooling. Now most window AC units, or at least the modern ones, are designed to have a temperature split such as the Delta T split on the central AC units, but on the window units they're designed specifically for 20-degree difference Fahrenheit, which actually translates to 11 degrees Celsius temperature difference between the return and the supply. So currently on high cool, you can see the temperature went up a little bit. The more air, the more refrigerant pressure, and the more refrigerant pressure, the higher temperature the lines, or the refrigerant temperature, actually goes up. The more airflow you got in the evaporator. So that means a little bit higher temperature, but again, 8.1 degrees. That's 46.58 degrees Fahrenheit. Now we're gonna check the returner temperature and the intake air temperature from outside. Okay, we got the thermostat, the thermometer sensor, right where the thermostat is, right down here in the inside part. Right, not touching the coil, but it's right on this side of the return. We got a return temperature of 19.3 degrees Celsius. That's 66 degrees Fahrenheit, and the supply temperature was 8.1 degrees Celsius, which was 45, I believe, 46 Fahrenheit. So this unit's working exactly as it should, because the temperature split between the return and supply is 20 degrees Fahrenheit. Went up a little bit more, 9.3. It's dangling in between 19.3. Now this unit is designed to cool up to 18 degrees Celsius. Thermostat is actually set to 18 degrees Celsius minimum temperature, so we're really close to getting there. 19.3 return temperature. It's not too hot outside because it's 9:05 a.m. So now we're going to test the direct intake temperature coming into the unit from the outside into the condenser coil. So we're going to check that. I expect it to be 85 degrees, 84 outside right now. So let's check that out. Okay, got the sensor right in the intake. See it right here real quick. That's where the AC unit actually sucks air. It does have a duct because we had to put that in there so it wouldn't recirculate air, because you may see the unit's actually behind the air would actually hit the little floor we got over there. So it would recirculate air, so it would actually start pulling way more amps than when it should, and compressor would shut down because of the thermal protection that it has. Outside temperature is between 28.8 and 29 degrees Celsius. So I called it 84 degrees, so it's not too hot. It's in that range. It's 9 a.m. so seems to be running pretty good. Temperature split is exactly 20 degrees Fahrenheit. We've got a 66 degree intake and a 46 degree supply, so it's working just as expected. If we turn down the fan speed to low, it actually drops it way more. So it's running pretty good. It's a big ass unit. It's 85-ish. And it's actually getting warmer. 29.8. That's pretty good. But yeah. 9 a.m. That's probably usually on these days in January it's between 32 33 degrees Celsius, so it gets in the 90s, low 90s. That's what it is. So this is a very simple way to actually test your window AC performance and your central air conditioner performance as well. And specifically, window units are designed to have a temperature split of 20 degrees Fahrenheit. Central AC units, they got between 15 and 25 degree temperature split depending on conditions. Anything below 15 degrees temperature split between the return and the supply means unit needs to be serviced or checked. Anything over 25, 24 degrees Fahrenheit off the supply, that unit's not running right now actually. That's a 320 carrier unit. That means you probably have a dirty filter, you got some restriction in the airflow. So it's angling in 84, 85 degrees outside. So this unit's running perfect.